So this workshop is for you guys to learn pandas. If you don't know what pandas is, it's basically like a Python library that's used to in mostly data science and machine learning, where you could just organize and manipulate different aspects of large data sets. So what you really need to understand is you need to install it. And then as long as you have it installed, you can use it in any medium. You can use it in VS Code. You could use it in Jupyter, as long as it's installed. So as long as you install it with pip install pandas, you should be good to go. If you guys have a Jupyter notebook already set up, you guys can follow along. Just let me know and I can go a little bit slower. If not, then I can just proceed.
I think
I believe like VS Code also supports Jupyter Notebook file types. So I believe if you just make like a file named this, it'll turn into a notebook for you. Something of the sort.
I'll see if I can install it in VS Code.
Okay. So first things first, all you need to do once you have it installed is just import it at the very top. And so I'm just going to run that. So usually when you work with pandas, it's usually going to be working with pre-existing data sets where you have like, you download like COVID data off of like, the CDC or whatever. But in case you wanted to make your own data sets, you're more than welcome to. All you need to do is specify the variable, and then you could list all of the parameters like so in a giant list. It's like a list of lists, and then you can assign a name to each of the variables inside the list. So in this case, I have Ty, who's a junior, and that correlates to their name and year. And then I could print out the data set by doing so. If I run this, you can see that each one has a number, and then I have my column names at the top. You could also try, and I prefer this way if you make your own data sets, is to list out all the rows in each column first, and that way you can more easily, in my opinion, see what's going on. And this will give you the same exact thing. Right. Does anyone have any questions?
Yeah. Where can you see the workshop text as a whole?
Oh, this notebook in general?
Yeah.
I'm gonna upload it to the SE GitHub after this. So it's not available. I made this myself, but you guys are more than welcome to clone the repository once I upload it.
Oh, where can I find the link to the SE GitHub?
Oh, yeah, let me just get that for you.
All right, thank you.
So SCE, sorry, my cat. Courses. So this is going to be, I'm going to post it in workshops, but here is basically all of the different workshops that have been done here, mostly by Ty, but you'll find this somewhere in there as well eventually.
All right.
All right. So I'm just going to move on because this is all pretty basic. You will almost never have to use this unless you want to fabricate your own data in any way. But this is what we're really going to use Pandas for. It's going to be importing and working with our own data sets. And so you can import a majority, like a lot of different data types or data files, like from CSVs to JSONs. SQL files can also be worked with in Pandas. But in this case, we're going to be working with a CSV, and we're going to be working on a data set from the Titanic. We're just going to try and figure out with this data set the factors that led to survivability, in a sense. But I used this data set from Kaggle. Kaggle is a great resource for finding a bunch of different data sets. If you go here, no, not there, data sets. Here you'll find like stuff about Netflix, COVID, Wall Street bets, and everything like that. If you have a question on, if you ever want to find a data set on anything, Kaggle probably has it. Yeah, so this is, if you're curious about the key of the data set, here it is. But yeah, so in order to import it, we're just going to use this command right here. We're going to set our data frame, which is df, and then to equal the CSV file, which I already have in here. So this is the path to the data set, which is in Titanic, and then I think it's train.csv right here. And then so I run that, and then you can see all of the data from that data set is all nicely formatted for us right here. So now that we have our data, we just want to figure out, like a quick all summary thing of the data set. So we can do that by specifying which data set we're referring to. In this case, it's our data frame, and then just run the info command on it. And you can see a bunch of interesting things, like how many non-null rows there are, and the data types and all of that. So when we're working with data, we generally don't want to work with data types that are like have nulls, because that will skew our data or our stuff in a general direction. So if we use the unique command, you can see like the number of unique rows inside each column. So in the sense that if you had like a pizza column, and you had 2 pepperonis and then 1 cheese, you would get 2 values. So if we go look here, we can see that survived has 2 unique values, which is 1 or 0 in the case that they survived or died. There are 88 different unique ages, all that kind of stuff.
Mhm.
If anyone has any questions, they can speak up, but this is all pretty introductory right now. Nope. All right. So now let's say that you wanted to view the data set just by a specific column, right? And so in this case, I just wanted to see the ages of all of my passengers. So all I have to do is specify the data frame, and then whichever column I want to view. So if I want to view a single column, then I just use a single bracket, right? So I specified the age, and you can see it all right here. But in the case if I want to view multiple, I have to use a double bracket. And then that would give me the age and the class of the passenger. It's all pretty straightforward so far, yeah?
Yeah.
Okay, good. So if I wanted to get a specific like set of passengers, like I wanted to slice the data set like a slice of cake and take that piece of cake and view all of the rows in that piece of cake, then you would use this command ilock. which is basically you specify it, then specify the command, and then you'd specify which lines you wanted to see. So this is the start index, and this is the end index, right? So if I wanted to view this, you see, I can see all the passengers from number 300 all the way down to 350, right? So just in case you wanted to just get a small sample of if you have like a data set of 1 million, right? And you wanted to create a script that would split up your data set into, groups of 1,000, then you would basically make a script that would use this command and it would shoot out a bunch of different data frames with 1,000 each that you can just view yourself. Does that make sense? Yeah. Okay, good. All right. So now this data set, right, has a bunch of different columns, right? If we go back to the key, we can see that it has a bunch of like columns like number of siblings, which port they embarked from, a bunch of different things, right? Not everything from this list will be very important to what we're trying to look for, which is the factors of survivability, right? So we can drop different columns manually before we even start analysis. So you just use the drop command, right? So I can drop, the ID, the name, and then the ticket number, for example. The axis will tell you it'll tell you if it's a row or if it's a column. So 1 will indicate that we're dropping a column, and then in place, true will mean that it doesn't create a duplicate data frame. So if I run this, and then I run the data frame again, you can see that I've dropped the ID, the name, and the ticket number from all the passengers. So if we want to select data by condition, say that I wanted to get all of the different females from the data set, right? Then we can just view it this way. You specify the data frame, and then the column, and then the condition right here. So in this case, we want to make sure that we want to select every row where sex is female. And so if we run this, we'll get all the different females. Pretty self-explanatory, right? Yep. And so now I just have a little exercise right here. I just ask for, the ticket class and age of passengers who survived from rows 300 350, but I already have the answer here for some reason, but that's just an exercise for you guys to play around with if you guys if you guys are doing this on your own, of course. But I'll just move on. So this is all just basically navigating through your data. We haven't really touched anything. We haven't really done any analysis on it. So now we're going to go on to aggregation, which is where you'll see like all the statistics and all the fun stuff, really. So the describe function is like one of the most important functions, I think, in my experience when working with pandas. It'll tell you a bunch of useful information about your data set. And so if we run it right here, so you can see that we have like standard deviation. We have the numbers of unique, or just the number of rows in each column, the average, etc. Yeah. So if you want to check the distribution of data in a specific column, like for example age, you would just do dot value counts and just specify which column you're going to use. So in this case, age. So we can see the distribution of ages across the whole data set. So in this case, there are 30 people. The majority of people are 30, and then the next is 27, 26, which is why the I believe the average of age is around 29 right here. So this kind of checks out, right? So that's statistics, just a basic overview of your data. And so now if we want to see correlation, so the correlation that all of these columns have on each other, we can just use the CORR command on the data frame, and you can see this. So the higher the absolute value of the numbers you see here, the higher the correlation, right? So you can see that, if they survived, then of course they survive. But in this case, we are looking for the columns that have the highest numbers for surviving, right? And so we can see that, maybe passenger class is pretty important. Maybe the price they paid is pretty important. So those are two things that we want to keep in mind for now. Right? Does anyone have any questions right now?
I have a small one.
Yep, go for it.
So if you go up a little, there was the part about where you pick the females.
Mm-hmm.
So does that mean that, like, what do the 3 dots mean? Does that mean that it was all males in between? And they
No,
just skipped?
so this is just basically saying that there's a bunch of different rows. So you can see that there's 314 rows in total. It just went for the top 5, and then it showed you the bottom 5. But the middle is like the rest of the 305 rows missing. If that makes sense. It doesn't show you all 300 rows.
But there is more, so there's more than what's being shown over here.
Yeah, exactly. This is just a brief overview.
Okay.
Any more questions? Nice. Okay. So now we have to go through and clean our data set a bit. So like I said before, we don't want to work with any null values, because null values will skew our data in ways that we don't want them to be skewed. So in this case, we want to find any null values inside of our data. So we can just say, specify our data set, and then hit it with the is null. And then I just do sum here just to summarize everything here. Right, so in this case, we have 177 null values inside of age, and 687 null values in cabin. So there are 2 different ways to go about replacing or cleaning your data. 2 ways. So you can replace them, or you can remove them. You can remove them by using the drop command. This will drop any null value, and as before, we use in-place true to not create a duplicate. You can drop columns with null values, which is probably a little bit more dangerous in this case, because if there's even one thing here and there's a null value, you'll get rid of all of the data inside of this column, even if there's one null value. And then you can replace null values with the average of the row. So let's say that I have, an average of like 29 of age, was it? Yeah. So let's say that our average for age was 29. And I wanted to replace every single null age in this column with 29. Then I would just run this command right here. You would specify the data frame, and here we would place age. We would fill null values with the mean here, but this would be the same as age. So this would be df age, fill na, age, and mean. Does that make sense?
Yes.
Cool. So we're just going to drop all no rows just to make our life a little bit easier. So let's go and do that. And so you can see our data set shrunk considerably because we probably took out about half of the rows. But that's okay. Now that our data is squeaky clean, we are going to run a little bit more, some more navigation, just a little bit more. So if you wanted to group your statistics by a certain column, we could group. So is everyone familiar with SQL a bit?
Yeah.
Yeah.
A little bit.
Yeah, a little bit. So are you guys familiar with the group by function in SQL?
Yeah.
Yeah. So basically, right, if I have, let's say, a column called age, right, and I wanted to group everything by the age, and so then it would be like, it would say, everyone age 24 has, these averages, et cetera, et cetera. Does that make sense? Okay, I think I should just show you. So here in this case, we're just going to group by the passenger class, right? So first class, second class, third class passengers, and the means for all of the different statistics inside. So in this case, it would be the means of if they survived, their sex, their age, etc., etc. So if we run this, right, so we can see that the first class passengers paid considerably more than the lower class passengers, but they were also considerably older, had more like familial stuff, and they survived just a little bit less than the second class citizens, right? But we can do a little bit better than that. If you remember from the Titanic movies, they always said women and children first. So we can add more than one column to the group by function. So let's group by class and sex and see what the result is. So we can see that first class females had the highest rate of survival, followed by second class females, followed by second class males, followed by third class females. So we can assume that if you are a rich person or if you are a woman, you probably would have survived the Titanic crash. So here we're just gonna go through merging data frames. So for example, if we had two different data sets, right, and you wanted to smash them together into one, we would use the merge function. This is bugged out for some reason. I tried testing it, but basically what you would do is I just created a second data frame with just some dummy numbers, and then I tried to smash it into. I tried to combine them with the merge right here, and then I merged on right and on name. So by doing this, you basically say, oh, I want this data set to have precedence over this one when merging columns, and I wanted to merge on the name row. If that makes any sense. I lost someone. It's okay. Does that make sense to everybody? So if I run this right, it'll say, oh, key error, everything. But in general, this is the syntax you want to follow. So if you have two different data sets that have, generally the same same content, right? So I have two Titanic data sets and I want to merge them in and do analysis on both of them at the same time, then you would merge them, and then, you would clean them, merge them, and then do the analysis that we just did on the single merged data set. Does that make sense? All right. Yeah, okay. All right. So we're going to go over one last thing, I think. Yeah. One very, 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 very important thing when it comes to pandas is the apply function. It lets you manipulate your data super efficiently. So in the case that I have, let's say, 1 million rows in my data set, and I wanted to change the rows, right? I don't want to spend the time going through the whole data set and then changing one value at a time, right? That takes too long. I would rather write something to do it for me, right? So this is where the apply function comes in. It lets you apply whatever you want to your data set using a custom function. So let's say that I wanted to change the age of all of my passengers, right? Let's say that we went through some time machine and, we got all of the ages wrong. And so we write our function, right? So in this case, I have change age. So if x is greater than 30, I want to increase the age. And then if they're younger than 30, or if they're 30 and younger, I want to subtract their age. And then I want to return the new value, right? And then so I'll make the function. And then now we can apply that function to the age column, right? So then I set the age column equal to this new age column after I apply the change age function. Does that make sense? So this lambda x just generally means that it's a single. Go ahead.
I don't know if it's just me, but the stream looks really low quality.
Oh, okay. Let me see.
Yeah, now it's better.
Okay. Where did it die at? Do you see everything good?
Yeah, now everything's clear.
Okay, so to reiterate, right, if we wanted to apply our change age function to the age column, we'd specify the column that we'd want to change, and then set it equal to the column after we apply the apply function to it, right? So in the apply function takes a single function. In this case, we're feeding it a lambda function. And a lambda function is just a function that takes an argument and performs a single expression. So in this case, we are going to change age x, and we are going to run this, right? We're going to look at all of the passengers' ages right here. So we have 39, 36, and 3, right? If we run this again, you'll see that it's 40, 37, and 2. Right, so it's super useful in case you're working with super large amounts of data and you want to change the rows in some way to make it more correct or do something with, right? Does that make sense? This is one of the most important things, so this is something you guys should remember well. Yeah.
Can you talk again about the lambda x?
Yeah. Okay. So lambda x, this is a lambda function. It's a function that takes that. It's a function that performs a single expression on a variable, right? And so we define our variable x, which is the columns in age, or the rows in age, right? So this would be x, this would be the x, this would be x, right? And then the single expression would be our function, right? In this case, our change age function, and then we feed it that variable. Does that make sense?
Yeah, in some
Okay.
way. Yeah.
Yeah. And then basically, then after we apply that lambda function to the data frame, it would increase or decrease the age depending on what we set right here.
Oh, got it.
Yeah. All right. Cool. So now that, we've changed our data a little bit, we've figured it out, rich women get to live on the Titanic. Let's just, sort our data and then we can export. So if we want to sort by, just to make it look nice, if you wanted to sort, you can sort by any column you'd want, but choose something that makes sense. In this case, I'm going to sort by the passenger class. All right. And so if I do that, we can see that everything is sorted from increasing to or from lowest, in this case, quote, highest class passengers to the lowest class passengers. And then we can rename columns to make sure that, everything looks nicer, just in case, people don't understand the key, right? So we rename it by using the rename function. We sort by using sort values. So if we want to rename, we use the following syntax. You put the original and then what you want the new column to be called. So original, new column, original, new column. And then in place is either true or false in case you want to duplicate the data set or not. So let's run this and we can see that now our columns are nicer to read. And now we can export it. So I'm just going to I named it final.json. Right. Okay. So I will. How do I do this? Okay. Here's what we're going to do. We're going to name this final2.json. So we have this new data set, right? And I want to export it into a nice and readable JSON file. And so if I run the data set, the data frame that I want to export, and then the file type I want it to be called, or the file type I want it to be in, and then I specify the file name and run it, we should see that the new file has been generated in the directory that you're in. And that's pretty much it. That's all I have. These are all the very core basics of Pandas. It's just basically, it performs statistics for you. You can manipulate and view data sets pretty easily. It's just very useful for just viewing, working with large amounts of data. So does anyone have any questions? I went through that pretty fast, so.
Yeah, I think I get a general idea of what Pandas does, so I think that's good.
Yeah, that's good.
Thank you.
Yeah, no worries.
Pandas Workshop works. Thanks.
Oh, thanks. All right. Well,
So,
there are. Oh, go ahead.
Actually, I'm wondering, like, if I'm interested in like machine learning or data science, that kind of stuff, like, is there any suggestions like how to approach those?
Just in general.
Yeah, just like the general.
There are. I would say there are like a bunch of. There's ML Club here at SJSU. They do a lot of different, like, small machine learning projects that you can do like in like an hour, 30 minutes or so. And they use Pandas, they use Jupyter. So I would I'd recommend to learn Pandas just a little bit. But yeah, I think just like viewing some tutorials, maybe playing around on, let's say, like Kaggle. There's some, I believe there are courses for you here. Yeah, so there's like introduction to machine learning and stuff like that. And they all have the data sets all there for you. So you can just play around with it.
Got it. That's
But yeah.
pretty useful. Thank you.
Yeah, no worries. Any other questions? All right. I guess that's it then. Thank you all for coming. Sorry for taking up your afternoon.
Thanks for the presentation. All right.
Thank you.
Yeah,
Or-
no worries.
See you.
All right.
Thank you, Lawrence.
Yeah, no worries.
See you.